am actually a scientist, although I will have to admit that I'm a social one. But I did go to Loughborough University, one of the UK's premier engineering universities, and spent 3 wonderful years living and studying with other engineers. So I have a claim to fame on engineering rather than an academic background. So why are we all here today? For those of you that weren't in the inaugural session earlier today, Future Tech Fest is the culmination of 8 months of work between the UK and India to increase tech collaboration, following an agreement between Prime Ministers Modi and May in April this year, to set up a tech partnership program between the two countries, linking the UK's industrial strategy, post-Brexit environment. There I go, I went about 2 minutes before I mentioned Brexit, and India's own industrial growth. We have over 100 UK companies visiting India, across India this week. Some of those are here today, focusing on everything from AI to future mobility, cybersecurity, and also fintech and capital raising, which is obviously an important part of supporting those sectors. Today's session on the future of manufacturing, as I mentioned earlier, is, you'll be happy to hear, not just about myself. We have colleagues here from business and government who are here today to help explain some of the work that we are doing and continuing to do on the future of manufacturing. Hopefully it will be an informative discussion. It will be an interactive discussion. As you all have seen, you've got some WYSI-Tech voting handheld devices. We're going to ask some questions of you all later in the session, which will be feeding into a piece of work that colleagues from the MTC, led by CEO Clive Hickman, are currently doing to assess and recommend where the future of manufacturing collaboration between the UK and India goes. And your responses today to some of the questions we will ask will be part of this research. So this, as I said, is very interactive, it's very relevant, and will feed into future work on collaboration between manufacturing between India and the UK. I've whizzed through my first 2 pieces of card quite quickly, so I'm looking at Clive to give him a quick heads up that I'll be introducing him shortly. But before we do that, I'd like to ask the panelists just to do that themselves, starting with Nick.
Thanks very much, Corin. Good afternoon, everyone. Nick Khanna, I'm the Managing Director for BAE Systems here in India.
Hi, good afternoon. I'm Kishore Jayaraman from Rolls-Royce.
Hi, I'm Naga Anumaya. I'm a Director of Central Manufacturing Technology Institute in Bangalore.
And I'm Clive Hickman. I'm Chief Executive of the Manufacturing Technology Centre in England.
Cool, thank you guys. So, as I mentioned, did I mention? I think I might have actually thought. About a year ago, colleagues in the BHC commissioned a report from Innovate UK on what the future of manufacturing collaboration between India and the UK could look like. And that was undertaken by a colleague, Nick Cliff. Nick, stick your hand up. Yeah, Nick. And basically they came up with 7 recommendations, 7 options for what would be the best way to develop future manufacturing collaboration between the UK and India. The next step, which Clive is going to talk to as part of his presentation coming up next, was to assess these 7 options and make a final recommendation as to what the future of manufacturing, how this could be developed going forward. So without further ado, I'll ask Clive to come up and talk a little bit more about the Manufacturing Technology Centre in the UK and the work that the MTC have been doing, as I said, to look at what the future of collaboration in manufacturing can look like. So Clive, if you'd like to come up, I think we're going to start with a short video and then presentation.
Hello, everybody. So this is a video that shows the Manufacturing Technology Centre, just a little run through of what goes on there. So this is going through our reception area. walking through into the workshop, and you can see some fairly startling pieces of kit. I really love this. That was a 20 kilowatt fiber laser. I'll talk a little bit more about that in a few minutes. Looking at some of the additive manufacturing capability that we have in the business, and some of our automation and robotics capability. And then this is really trying to simulate augmented reality, and the augmented reality we do. This is a number of the partners that we work with in MTC across a wide sector of activities, and looking at various capability that we have. I guess you'll recognise that as a fan blade for a Rolls-Royce Trent engine. And this area here is where they look at non-conventional machining, and then just an overview of the whole site. Good. So give you a little bit of an overview of what it's about. We'll get some slides coming up, I think, in a minute. Maybe. Are they loading? Nothing. There's nothing working on the clicker. Oh, here we go. Oh, I've gone way past now. Okay, good. So, Manufacturing Technology Centre, we've seen the video. A little bit about the facility. It's founded in 2010. We're an independent RTO. We're a company limited by guarantee, which means that we don't distribute any profits. All of the profits that we make are reinvested in the business, and it's a purpose-built 12,000 square metre facility. Was the first facility that we had. We've now got probably 4 or 5 times that amount of space within the activities, and we were founded by the University of Birmingham, University of Nottingham, TWI, and of course Loughborough University, Nick, where you where you went there. Yeah, I went there as well. So yeah. So Loughborough University is one of our top universities in the UK. So our strategy is about creating a positive impact on society, and we have a vision of inspiring great British manufacturing on the global stage, with a mission to generate rapid and sustainable growth by delivering integrated manufacturing system solutions. And we base everything that we do on the 5 strategic imperatives. If anything that's presented to us doesn't match those imperatives, one or more of those imperatives, then we wouldn't get involved. So it's about accelerating industrial growth, delivering innovation, changing the way business is complete, creating and embedding skills, and driving synergies into the supply chain. And as I say, with this overarching purpose to create a positive social impact. We're part of the High Value Manufacturing Catapult. The High Value Manufacturing Catapult in the UK is 7 centres. The 7 centres are listed down on the right-hand side of this slide. I guess I'm going to lose this if I try to talk this way. So we've got the AFRC, which is the Advanced Forming Research Centre. So it's forgings and formings based in Scotland. The Centre for Process Innovation, which is predominantly looking at chemical formulations. The Nuclear Advanced Manufacturing Research Centre, which is about civil nuclear programs. The Advanced Machining Research Centre, which is really focusing on advanced machining techniques. MTC, I'll tell you more about. Warwick Manufacturing Group, that I guess many of you have heard of. These days predominantly focusing on battery technologies for the future. And then finally, the National Composite Centre, which is based in Bristol and is focused purely on composite manufacture. So this is the MTC campus. We saw a little bit of a fly around of the campus. So this building is our main manufacturing area. At the back here, we have a advanced manufacturing centre for aerospace. So we call that the Aerospace Research Centre. And then at the front, we have our training centre. We found early on that unless we train people in the technologies that we develop, then those technologies would stay at MTC. We talk about the skills gap in the UK. If we don't train the people to use those technologies, again, we'll still have a skills gap in 5-10 years' time. And then the top right, top left, that's a high temperature research centre, which is predominantly aimed at advanced blade casting activities for Rolls-Royce. So what do we do? We tend to focus on what we call the TRL level, the technology readiness levels, and we classify technology readiness from 1 through to 9. 1 is when somebody comes up with a bright idea in university. He works through with that bright idea until he gets a proven concept at probably TRL 3. That's when we come in, university passes the baton to MTC, and then we take the technology through that applied research phase and into technology implementation with industry. And when we look at our market segments, what I would say is that MTC is about process development, and the processes that we develop are applicable across a wide range of sectors. And so our markets, aerospace, automotive, construction, infrastructure, electronics, energy, food and drink. You know, we take technologies that we're working on with Rolls-Royce and we apply them in the food and drink sector. And likewise, we can get technologies that come from the food and drink sector that we apply back to things that we're looking at with Rolls-Royce. Oil and gas, military and defence. So really it is about process, it's not about product. So what that gives us is an open access environment where people will come to develop process, because developing the process isn't the IPR that the company wants. The company's IPR is based in the product, not the process. So we've talked about this before, working to accelerate industrial growth, deliver innovation, change the way businesses compete, create and embed the future skills that we need, and maximise synergies within our supply chains. The 4 technologies that we are predominantly using are intelligent automation, and that's where we're linking robotics with lasers, with sensors, with optics, so that we can bring a degree of intelligence to the robot. So instead of the robot carrying out a single task, we can now get robots that are multitasking, doing several jobs, being able to find a component, pick up that component, take it to where it needs to be fitted, fit the component, and then look for the next component. So if we take something like if we take something like a car, and you would see a body plant that's got several hundred robots, we can actually build the body of a car with 2 robots. It takes a little bit longer than the full system that's in a car plant, but it's very, very flexible. And what it means is that with the 2 robots, we can change the product that's going down the production line at any point. So we're not fixed on one product. And that becomes really interesting for the auto sector, where one of the biggest costs these days is the logistics. So if I take Nissan, for example, Nissan make the Infiniti in America, they make the small Nissans in Japan, and they make the Qashqai in Europe, and they ship those all around the world. With the technology that we're developing, we can make all 3 of those Nissan product lines on the one body in white plant. And that then becomes really game-changing for product manufacturing for the future. Additive manufacturing, I guess you've all heard of 3D printing. We call it additive manufacture, which is looking at dense metal alloys and how we can develop those for the future to make future products. A lot of the technology that we use there is around the powders, and we found that the pharmaceutical industry really knew how to manage powders. We came to apply powders, and we found that when you make one with a powder, you can get one product. The next product is completely different. It's all about the particle sizing, the particle density, and the size distribution of particles in the batch. So we used the pharmaceutical industry to teach us how to use powders for the automotive and the aerospace and the rail industries. I've got a couple of samples. This is a little ball that we made, which is made with titanium. And the question that I always ask, does metal bounce? And you're all going to say no, and I'm going to try and prove differently. I hope you can see at the back, but this is a titanium ball. It just bounces back. That floor isn't so springy as some of the other surfaces I've used, but I was able to catch the ball when it bounced back. Who would believe you could do that with metal? And then if I look at a fuel injector, I think the next slide shows a fuel injector. I'll pass these round and you can see them. But the fuel injector is normally made out of about 15, 20 different parts and then assembled together. By 3D printing, we can print the components in one, which saves lots of time, lots of money, improved accuracy. This one we've sectioned. We didn't actually section it after we'd made it. We sectioned it in the machine before it was made. So we just laid down the powder to give us section part. I'll pass these round if people want to look. We talked about intelligent automation. We talked about additive manufacture, laser processing. We're seeing so many things now where lasers are coming into play, becoming a real major area for us to develop for the future. Typical example: if you take a railway wheel, when the train breaks, you put a flat spot on the wheel. To get rid of the flat spot, it's traditionally ground. You can only ground the wheel 3 times, then you've lost the structural integrity. If you can build it up using lasers with powders and then grind it using the laser, all of a sudden you're improving the life expectancy of the wheel. We're in the process now of being able to translate that onto the track. So when you've got a flat spot or wear on the track, we're looking at how we can build that up in situ to take the people away from the track, so that we're getting them out of the dangerous zone of working on a railway. And we're looking at the point where we can have a train that travels overnight, a goods vehicle, laying down the powder, polishing the track, inspecting the track and making sure that we're repairing the track overnight, which will increase the throughput time of vehicles on the railway. And then finally, digital engineering. This is about 50% of our business is now in digital engineering. And we were talking a little bit about this earlier in the forum outside. And for me, you know, when people talk about the fourth industrial revolution, for me that's about being able to make a bespoke product at the same price point and in the same time scale that you'd make a mass-produced product. And so when we're able to link our digital engineering capability back with these other technologies, all of a sudden that becomes game-changing for the industry. Augmented reality, linking those things together. One of the things we talked about earlier was how we went into virtual reality, learning from product design and taking virtual reality into the manufacturing environment, looking at how we can lay out a factory to get an optimum throughput for the factory, the design of the factory, and taking that on then to augmented reality, where now we can develop a factory in a box. We can deliver that factory in a box anywhere around the world with robots, with lasers, with additive manufacturing machines, and then we can codify the manufacturing process and control that absolutely from a control center back in the UK. That gives us an ability to improve the quality, the productivity, and control costs much better. And then when we get a problem in that factory, rather than having to send somebody who's a trained expert in that field, we can use augmented reality to send in a man local to the region and then show him what he needs to do when he's in the factory by being able to point to the point of the failure on the plant or the change in the plant, and then walk him through the process using virtual reality through the goggles interface directly into the manufacturing cell. And I think that really is going to be game changing and changing the way the businesses compete for the future. So the High Value Manufacturing Catapult was founded in 2011. We have an order book that's about £188 million. We have £560 million worth of assets that we're dealing with, 2,000 people, and we're working at any one time on about 2,000 innovation projects. As part of that, this is the MTC story. So when we set up the business in 2011, our first year, we turned over £160,000. We had 10 employees. I was number one employee, so I'm responsible for this £160,000 turnover. More importantly, in that first year, I was responsible for the £800,000 loss that we made. So that was quite an uncomfortable ride at that point in time. But I give you that message because, you have to sort of invest to bring forward the capability that there is for the future. And right now, sort of 2018, we're turning over £72 million. We have 820 employees. We're working with over 100 companies at any one time and working across these technology themes. So the growth of a manufacturing business in a 7-year period is pretty astounding. We think there's the opportunity for that to be done in India as well. But we have to recognise that there's an upfront cost to do it. We have to recognise that it's not going to be an overnight success. It's going to take a number of years to build to this capability. And so, when Corin spoke earlier, he talked about this study that was done by Nick, sitting up at the back. This is the book. I don't know whether any of you have seen that. It's available on the internet. There's a web page where we can get it and we can give you the details of that. And it was talking about the future of India-UK manufacturing, to look at what we could drive productivity, economic growth and improve quality. The study looked at how we could get benefits from increasing collaboration, how we could provide specific recommendations on what should be done together, and then to identify the support mechanisms that were needed and a program of activity to take it forward. So we're now, within that report, there were 7-step recommendations which were listed down the side. I won't go through those in detail. But, excuse me, the next stage of the study has been commissioned based on those recommendations. We're calling it the Advanced Manufacturing Centre Options Appraisal Study, to look if there is a possibility of bringing a catapult-like centre to India, and if we do bring a catapult-like centre to India, what should that be? What should that look like? How should it be structured? What should be the capability of the centre? What should be the focus of that centre? And what benefit would it bring to Indian manufacturing? So MTC is carrying out the study on behalf of the UK and the India government. It's split into 2 phases. Phase 1 is discovery. That's a phase that we started this morning, and as Corin alluded to, something that we're going to ask you some questions about at the end of the discussion this morning. We want to map the current situation in India in terms of advanced manufacturing capability, support for innovation, where are the established centres of excellence, and what is the bilateral programs funding opportunities that are there. And then we're going to consider a range of centre models that could be applied to India with a short list of options that we can decide on whether it's viable or not viable. Phase 2 will be recommendations for that preferred option. So when we start to look at the models, we need to focus on what's required to help India achieve its full manufacturing capability and potential, focus on the growth and performance of critical technologies, and defining a strategy to address the challenges along that TRL journey that we talked about a little bit earlier. And where would India fit on this TRL journey? Where would a centre in India fit on this TRL journey. So I'm part of that study. Tony Campion, if you'd want to stand up and people can see who you are, is going to lead that study on behalf of MTC. If any of you would like to take part beyond the questions that we're going to ask today, maybe you could contact Tony. We've got some business cards and we can hand those out at the end of the session. So thank you. And for me, any questions before we move on to the speakers? No? Okay. Nick, back to you.
Thanks, Clive. So, yes, as Clive said and I mentioned earlier, MTC are in the process of doing the research that will support the recommendation of how a manufacturing centre between the UK and India will look, work, operate. So what we're going to do now is throw this over to you guys. Obviously, the views and opinions of government, academia and industry are crucial to informing this decision-making. So between ourselves and MTC, we've come up with a series of 15 questions, which we're going to ask you to respond to now using the handheld devices that you have on your seats. And for those of you that remember the Who Wants to Millionaire TV series, it's in that very much absolutely ask the audience. So we're going to give you 15 seconds to respond A, B, C, or D to the questions that I'm going to read out and are going to pop up on the screen. We're going to get an immediate response to see which answer you guys think is the most appropriate, the most relevant. There is no right or wrong answer, so don't worry, it's not taxing. It's just to get your opinions as stakeholders as part of this report and decision-making process. So if you've got the handheld devices, if you can now press the CE button to switch everything on. What we'll then do is run through the questions one by one. There are 15, as I mentioned. You'll have 15 seconds to make your decision. And once that decision has been made, after 15 seconds, we'll get to see how you have voted. So I'll give you another few seconds just to switch everything on. We'll get the first question up. And yeah, let's keep our fingers crossed that this is gonna work. Current tech supporting future tech. Okay, so first question. What do you think is the greatest challenge for manufacturing in India? A, increasing productivity, B, improving quality, C, reducing cost, D, increasing capacity. So 15 seconds on the clock. Go for it. We've got the sound effects as well. Fantastic. Okay, so 66% of you went for improving quality. Okay, interesting. Okay, question number 2. How do you learn about new technology developments? A, through academic papers, B, through sector or trade organisations, C, proactively through their own R&D departments, or D, by lucky accident. As I said, 15 seconds on the clock. No right or wrong answer. Oh, we're going for B's. 55% through sector or trade organisations. Okay. Question number 3. What is the primary platform for knowledge sharing around new technology developments? A, academic institutions, B, sector or trade organisations, C, conferences and summits, D, sharing threatens your competitive basis. No pressure for answering C on this one. Oh, we've gone for a C this time. C, conferences and, oh, thank you. I'll let my colleagues organising know about that. Okay, question number 4. How are collaborative risk-sharing R&D projects established? A, academic centres, universities. B, industry collaborations. C, through funding mechanisms such as Newton Barber, or none exist? I'm guessing I know the answer to this one. Oh, a bit more of a split on this one. So, okay. 25, 40 and 25. Okay. Question number 5. Which of these statements best describes manufacturing in India? A, made in India. B, designed and made in India. C, designed in India, made in another country. Or D, innovated in India. As I said, no right or wrong answer as such. Oh, strong leader, made in India. PM Modi will be happy about that one. Okay, question number 6. How are the majority of manufacturing skills and training needs met in India? A, through academic institutes and training centres. B, through academic institutes and training centres in other countries. C, internally through the manufacturer's own resources. Or D, on-the-job learning by doing. So Clive mentioned how important skills and training was for MTC. How do we think it happens in India? Oh, strong leader for D, on-the-job training. Okay. Question number 7. What is the greatest determinant of how a business develops their supply chain? A, best price. B, best quality, then price. C, collaborative products and processes are developed together. Or D, the customer specifies the supply chain business. A bit of a split, but still a clear leader for A, best price. Very relevant here in India. Question number 8. What are the opportunities for SMEs to adopt new technologies? A, in collaboration with customer. B, through trade organisations. C, with academia. D, at high risk. Yeah, a bit more of a split, but in collaboration with customer just ahead. Okay, question number 9. What drives technology investment in India manufacturing? A, a clearly defined growth strategy roadmap. B, market and competition forces. C, copying best practice. D, government funding opportunities. A little bit of a split, but yeah, definitely B leading the way. Question number 10. What are the opportunities for collaboration in advanced manufacturing between India and UK currently? A, many and the impact is clear and significant. B, many but the impact is unclear. C, few but the impact is clear and significant. Or D, few and impact is unclear. We deliberately didn't say working with the embassy, High Commission either. bit of a split, but yeah, definitely B. Question number 11. What are the barriers to growth for manufacturing in India? Low productivity, poor quality, application of new technology, skills shortage. Bit of a split again. Obviously, no one thinks it's low productivity, so D, skill shortage. Okay. Question number 12. What technology theme will have the biggest impact on manufacturing in India? A, digital engineering, B, automation, C, additive manufacturing, D, new materials. Broad themes, but let's see what you think. Okay, B, automation. Okay, question 13. What opportunities exist for knowledge transfer within manufacturing in India? Good links through sector and trade organisations, universities and training organisations disseminate knowledge. C, knowledge transfer is limited as it is seen as IP transfer. Or D, knowledge transfer is not perceived as important for manufacturing in India. Whoa, big split. But C, knowledge transfer just ahead. Okay, question 14. How is product innovation nurtured in India? A, through funded and supportive organisations. B, by wealthy individuals and businesses. C, product innovation is poor in India. D, through academic institutes. Almost direct split there, A and C. Final question, question number 15. What would be the best mechanism for advanced manufacturing technology transfer from UK, Europe? A, establish an advanced manufacturing centre in India. B, create a spoke in India from a UK hub such as MTC. C, create a hub and spoke arrangement in India. D, create a collaboration between UK centres and existing Indian centres. Another very close split between establishing a manufacturing centre and C, create a hub and spoke arrangement in India. Okay, interesting. Okay, so that concludes the Who Wants to Be a Millionaire Advanced Manufacturing Centre options. What we're going to do now is, obviously we will take those results and feed them into the work that Tony and Clive are doing. But given that we've got our panel here today, what we're going to do now is throw some of those results over to the panel and get their impressions and thoughts about what they think, why they think those results came up, and any other thoughts that they may have on some of those questions. So I'll kick off with looking through the questions. Question number 6. How are the majority of manufacturing skills and training needs met in India? We heard earlier from Clive how important skills and training is for the MTC and what they do back in the UK. But from you guys here, the clear runner, clear favourite with 78% was on-the-job learning by doing. So, Clive, seeing as you did mention that earlier and how important it is for MTC, and we heard some of the other questions around things like automation. One of the themes for FTF is AI. On how are the majority of manufacturing skills and training needs met in India, what are your responses about nearly 80% of the audience saying on-the-job learning and doing?
I guess from my experience of being in India when I was with Tata, I saw that pretty much the case, that people were learning on the job. And the problem that gives is that you can only learn on the job the things that already exist. So trying to bring the high-value manufacturing technologies such as automation or additive manufacture or laser processing, you can't learn on the job if you don't already have it in the factories. So it's going to be an impediment to driving forward unless we can create some good training opportunities in these new technologies.
Okay. Does anyone else on the panel want to comment on that question around skills and training?
Yeah, there is one problem in our academic structures, because in the engineering school or even for the training school, like industrial training school, the focus of teaching is how to score 98, not to 95. So this is the major reason. So that students are not exposed to the practical training. So more merely on examination based and curriculum based. I believe this is one of the major challenge. We don't have the kind of skilled manpower which the employer has to train on hiring.
Okay. Yeah, sure.
If I may, Corin, it's a very broad question to me, right? And when you look at this question, it's a combination of how we are educated. It's a combination of how you group the skills. Is it low-value skills, medium-value skills, high-value skills? You look at it in the manufacturing context. If you look at low-value engineering skills, we have the sort of the technical institutes in India, which do train people in some of those skills. We have focused on a lot of areas where we put out electricians, plumbers, carpenters, who are all into a formal organized sector anymore. There's a lot of effort going on there. But if you look at the high-value manufacturing area, definitely what Clive mentioned applies. And so I think in India there's plenty of opportunities for skills development in very different areas for very different reasons. And as product innovation improves, as things get to a different level each and every day, I think the skill requirement keeps changing. And the only answer to this is we understand skills are going to be ever-changing, needs are going to be ever-changing, and the ecosystem should be developed in order to enable the skill change, enhancement, innovation, productivity, whatever it is.
Okay. Thanks, Kishore. Nick?
Yeah, just to add to that, one of the things that we're seeing as a real pull-through, especially in the aerospace and defense industry, is the kind of innovation and the kind of upskilling that we're seeing out of the small and medium enterprises. And that spirit of innovation that is so crucial to high-value manufacturing, which is remarkably different from what Kishore pointed out, which is, as we see, sort of build to print, build to spec, which is pretty much what we're largely seeing in the private sector today, especially in the aerospace and defense sector. I'm speaking, specifically for our sector. And to bring that innovation out, we will need access to investment. We will need a complete change in mind shift and thinking in terms of how we teach and how we really encourage people to come through the startup community. There has to be access to capital. And if you combine all of those things, then you reach an alignment, I think, of skills and capabilities that will then hopefully align with the kind of high-value manufacturing areas which we're discussing today.
Okay, thanks. Following on from that question number 12 was, what technology theme will have the biggest impact on manufacturing in India? Digital engineering, automation, additive manufacturing, and new materials. And automation came out top with 50%. Now, obviously, automation in a manufacturing industry such as India has, or across many industries, where the volume of people working in factories, manufacturing is very high, can be seen as quite a contentious issue. So let me throw it over to the panel. What are your thoughts about increasing automation in India, which is obviously seen by the audience as being key, versus the effect that will have on jobs? Clive, do you want to kick that one off?
Okay, we do a lot of projects that are about automation and bringing automated processes into factories. And our experience is that you do displace people from the particular job that has been automated. But what you have to do is you have to put an upskilling program alongside the automation program so that you can retrain the people that are being displaced to do higher skilled, higher value jobs, and with higher salaries for those people as well. And we've found that we've never lost any people through automation. We've actually always got to a point where there's more recruitment going on as a consequence of automation.
I believe what is required is plant automation is already there, not least in big companies. But process automation, understanding the manufacturing process, so that is missing in India till now.
Yeah, automation is a natural pick, because if you look at the rest three, they are very nascent topics. Advanced manufacturing and other areas are very nascent topics, still evolving, emerging. And but loss of jobs with automation is always a debate that happens. And definitely upskilling is one of the things that has to happen as we automate more and more. But also we need to understand, why are we automating? Automating for the sake of automating, just to show that we are part of Industry 3.0 or 4.0, is of no value. And I think companies have to realize, if I don't have to automate the process, and if I can live with a 4 Sigma quality standard, then why would I automate it? We have enough people in this country who will perform the jobs at a cost level. They've been trained, we have sunk cost, and we have to look at it as in the context of the environment we live in. And a lot of times, we miss that point. If you look at advanced manufacturing, like additive manufacturing, I think their automation becomes a must. Without saying it, it becomes automation. So the key thing to think about is, leave the present industries, these sunset industries that are already automated, continue to increase the productivity through automation. But in the sunrise technologies, I think automation will play a very key role. And I think there we have to create the skill set. There we have to think about how these skill sets are going to be created, and how will you make them sustainable into the future. I think that's the way I look at things when it comes to automation.
Yeah, I'll just add just one quick point to that. So I think disruptive technologies in the form of additive, wearable technologies, and automation is clearly the direction of travel for the future. That is, I think, something that, as Kishore pointed out, is something that companies need to come to terms with. And if India is going to differentiate itself now among other emerging players as a world leader on the high value chain of industrial capability and manufacturing, getting into some of these emerging technologies allows India to actually leapfrog other Western countries, and actually becomes a differentiator, because so far it's been low cost labor arbitration. It allows it to sort of move away from that discussion, and through the skilling opportunities, through the right level of focus and the right level of support from the government of India through skilling programs, it allows it to now really begin to differentiate itself amongst sort of other countries in the region.
Could I just add? For me, the other thing about automation is the improvement with quality that comes from automation. And the quality improvement comes because people change, and people's mental state changes. So somebody who's doing a good job, most of the time, if he's had an argument with his wife before he comes to work, or his children are struggling at school and there's something playing on his mind, he's thinking about other things rather than his day job, and that's when the quality slips. It's where automation can actually take that away, because the robots don't actually worry about family life.
Okay, interesting last response. Nick, I'm going to ask you to respond first on this next question, and then Kishore. Question 7 was, what is the greatest determinant of how a business develops their supply chain? And the options were best price, best quality then price, collaborative, products and processes are developed together. The customer specifies the supply chain business. And maybe not unsurprisingly, best price came out top with 45% of the audience focusing on that. But what are your thoughts? I mean, particularly working in a high precision, high quality industry such as aerospace and defense, in terms of price versus quality.
Yeah, I would respectfully disagree that price be the only sort of criteria for us in the aerospace and defense industry. Ours is a zero defect industry. So while our colleagues and friends in the automation in the automotive industry can still handle a fair amount of defect, we deal with safety of life systems. So for us, it's an absolute zero defect industry. So we have real rigor in what we put our suppliers through in terms of the due diligence, in terms of the very extensive quality and engineering sort of evaluation to approve them to become a global supplier to us for our UK, for instance, for our UK MOD programs or for our US DoD programs. So it's not just price, it's quality, it's process automation, it's adherence to those MIL standards, STANAG, the sort of requirements of the UK MOD and the US DoD, setting up, ITAR approved facilities, through access control and all of those kinds of things. I mean, there's a whole list of things that we put these companies through. So it's price, quality, and then a whole range of other metrics that we look at that really get these guys through the gate.
Well, obviously, when we look at India, everybody outside looks at India as a cost arbitrage. So that point of price as a consumer in India, the first thing I look at is how expensive is it? Or do I look at it and say, is this going to last for a long time? Technologies keep changing, and in every area, it's a differentiation between price and quality, and it's going to be about collaborations and partnerships. So, in my view, I honestly believe India should find itself definitely on the cost arbitrage curve, but there is a value arbitrage curve that has started. And if India does not evolve into the value arbitrage curve, we will soon find ourselves a country where we'll make cheap products that break faster, right? What we need to do is we will make the right cost products that will last longer than everybody else. And then we have differentiated ourselves to become the next manufacturing hub.
If you want to, Dr. Ladahima.
Yeah. Yes, cost is important parameter. The reason is, one of the reason is the scale of operation, because many of industries are small scale industry. And second is, unlike other countries, normally Indians look at for 3 generation. So how I eat, how I feed my son, and how he will feed his son. So that is where actually the taking risk becomes the major issue. Otherwise, yes, Indian companies are looking for the quality now.
I think that I would say it's better to pay too much than to pay too little. Because if you pay too much, all you lose are a few rupees. If you pay too little, you risk everything. And we've seen it in Europe where companies have failed to survive because they've cut corners, they've cut costs, and their product quality has dropped to a level that nobody buys the product anymore. And I think that's a risk in India. I think particularly in the Indian auto sector, it's a big risk. And it's better to pay too much than to pay too little.
Okay, thank you. A sort of differing opinion from the panel to the audience on that one. I'm going to ask one final question because I'm conscious that all that's standing between you guys and lunch, yes, is how many questions I ask. So I'm going to ask one more question, and it's probably the one question that Tony and Clive would like to have the most feedback on. The very last question, question 15. What would be the best mechanism for advanced manufacturing technology transfer from UK, Europe? Establish an advanced manufacturing centre in India, create a spoke in India from a UK hub, such as MTC, create a hub and spoke arrangement in India, create a collaboration between UK centres and existing India centres. Now, interestingly, the response which was the lowest was create a spoke in India from a UK hub, with establish an advanced manufacturing centre, answer A, and answer C being pretty much equal. So I'll start again with Nick to give Clive opportunity for some closing remarks as well. So Nick, in your opinion, from a BAE point of view, how do you see the future for collaborating between UK and India manufacturing, particularly in relation to a potential manufacturing centre?
So I think I'll start by giving a plug to Clive's presentation, because I think the establishment of a high-value manufacturing catapult in India would indeed provide a significant boost to the Indian economy. It will set the tone, I think, right from the top, with the right and adequate support from the government of India, the right participation from leading companies that we had at our discussion yesterday, the likes of Tata, Mahindra, Bharat Forge, who are already galloping, quite fast into Industry 4.0 kind of capabilities. But it also sort of differentiates India from the low-cost labor arbitration kind of discussion and into the higher value chain. It also creates a real outreach for the sort of ability to create centers of excellence in the country. And like I said earlier, if you want to leverage what people like Ratan Tata have greatly helped in, which is the advent of the startup community in this country, then you pull along some of the small and medium enterprises as well along with you through that journey.
Yeah, I was just thinking about what the right answer could be in this case. In my view, all four could be right and all four could be wrong. The reason I say this is when you look at sun rays, right, when it's diffused, there's really, the heat is not felt enough. And when you take a magnifying glass and you just focus these rays, you all of a sudden find yourself generating heat and fire. So to me, you got all these centers already developed. They all do some specialities. And I think there should be a nodal center that will definitely take the leadership in this. But the participation of the rest of the centers in order to create something in India, because India is going to need a lot of these technologies, a lot of processes, a lot of interesting developments that we can have. So I think I would look at all these different centers that have been created that Clive showed just before, the catapult centers, and then let them all participate appropriately in this with a leadership done by MTC. And then India becomes a center with having an advanced manufacturing center in India that incorporates the best of the projects, everything, and also has ability to access resources from different places in order to achieve what we need to achieve. I think that'll be the best way as we go forward instead of just emulating one model or two models. I think India needs a lot more than just one or two models.
I agree with Kishore. There is a lot of thrust in India government corridor for advanced manufacturing. At the same time, the basic expertise is required. It is already there. It is existing. So now only thing is we have to figure out which center could be a nodal and for which kind of technology. I think then bring in to the industries consortia into this. I think this should work.
I'd just like to thank everybody for the input that they've given us. I'm not going to answer on this question because I want to listen to what everybody in India has got to say, because that's far more important than what I have to say. We really need to get this right for India. I think I would agree that trying to replicate MTC as a spoke from a hub wouldn't be the right thing. But other than that, I want to find out what really is right for India over the course of the next 2 or 3 months. So we do the right thing and we get India in the right place with these high-value manufacturing technologies. Thank you.
Cool. Thank you, Clive. Is there any final remarks, Clive, before we wrap up?
No, I just thought that it was a good debate. Thank you to my colleagues for their support. Thanks to everybody for voting on and having the patience to vote on the various things. I thought it was good fun. nice to see the results, and I'm looking forward to doing some more analysis of that data over the coming weeks.
Okay, so yes, sorry, Nick, one last word? Yeah, sure.
One last point, and it goes to your point, sir. We should leverage what the IITs and the IISCs are doing, especially IISc Bangalore, IIT Bombay, IIT Madras are just 3 examples where some of the thinking that is quickly going into some of these areas is very exciting indeed. And if you look at what some of the leading research and technical institutes in this country are doing, there is a real opportunity to try and include it into some of that thinking, and then come up with the most appropriate or the best fit kind of a center. IIT Bombay, IIT Madras, and the Indian Institute of Science in Bangalore. So those are the 3 examples. I'm sure people in the audience would have some more as well.
I had to say this. I'm sorry. IISc Bengaluru, IIT Mumbai, and IIT Chennai. All the 3 cities' names have changed.
Okay, so it just reminds me to say thank you very much to the panel for supporting the session today. Thank you very much, everybody, for coming along. Watch this space. Stay in touch with the British High Commission and MTC websites to see where this report goes and what the final outcome is. I'm not going to ask for questions because I'm probably going to get kicked out of the room very shortly. You need your lunch, so at the risk of eliciting the panel's wrath, I'm sure they'll be around the lunch area, which is out on the lawn, so do try and grab them subsequently. So yes, finally, thank you very much again from myself, and enjoy the rest of Future Tech Fest.